So electric circuit question 16, the classified paper. Figure 7.1 shows a diagram that include the component X is there. State the name of component X. So what is this X? The circuit symbol. What X is representing? Which component? Yeah, that's right. X is representing a thermistor. X is representing a thermistor. If it was a variable resistor, then there should be an arrow. You have to learn the circuit symbols. If it was an LDR, light dependent resistor, then the arrows are pointing inward. But this is a thermistor. And thermistor, what happened? Its resistance is inversely proportional to temperature. If temperature increases, its resistance will decrease. The electromotive force EMF of a battery is E. The switch is closed. The potential across the 30 ohm is V30 and the potential across the 20 is V20. The potential across X is Vx. State the equation which relate V30. Look, they said the voltage here is V30 and voltage here is V20. What is the equation? And the voltage here is Vx. Because they are in parallel. So when two components are in parallel, what is same for them? Voltage or current? If the two components are in parallel, which quantity is same? Voltage or current? So voltage will be same. So if voltage here is V30, voltage here will be V30 as well. So we can say that Vx will be equal to V30. So Vx equals to V30, or voltage across a 30 ohm resistor is same as voltage across X. And relation between E and V20, how E and V20 are related? If the total EMF is E and out of each some voltage drop here, what is the remaining voltage will be there across this component? So we can say that the total volt, like if I say total voltage is 10 and out of 10, maybe 3 volts here. So what happens? Remaining voltage will be across this parallel combination, which is 7. So how we can relate the Vx with E and V20? So we can say the EMF, the total voltage minus the voltage across the 20 ohm resistor will give us the voltage across X. So Vx is equals to the total minus the voltage across 20. Then the EMF of a battery is 6 and the resistance of a component X is 15. Calculate the total resistance of the circuit. So if you want to calculate the total resistance of a circuit, so this is 15 dimension. This is 15, this is 30. First, these two are in parallel. So how to work out the combined resistance? So it will be product divided by sum. So it will be 15 into 30 divided by 15 plus 30. What's the answer for this part first? 15 into 30 divided by 15 plus 30. That is
equals to
10. So if this combine is 10 and this one is in series. So what is the total resistance of a circuit? So total resistance of a circuit will be 10 plus 20, which is 30. So we first work out the combined resistance of this combination and then add to 20 because that is in series. So the total resistance of a circuit is equals to 30 ohms. So the total resistance of a circuit, that's equal to 30 ohms. As first we work out the parallel combination and that parallel combination plus the series one to get the combined. Then ammeter reading. So we will have the formula V is equals to IR. The total voltage is 6. Total current we don't know, and total resistance of a circuit is 30. So it will be 6 divided by 30. That will give us a total reading on ammeter, that is 0.2 ampere. So 0.2 ampere is the total current in the circuit. Then in terms of component X, the temperature of component X increases. State and explain what happened to the ammeter reading. Look, if component X temperature increase, its resistance will It's a thermistor. So if the temperature increase, what is the relation between temperature and resistance for thermistor? It is inverse. So if the temperature increase, the resistance will decrease. And if the resistance will decrease, like first it was 15 ohm, first it was example 15 and 30. So we were getting a combined resistance of this, all combined resistance was 10, the combination. But what happened as the temperature increase, the resistance of a thermistor will decrease. So say we are taking 5, just to explain the idea. Say this was 5 ohm and this one is still 30. So it will be 5 into 30 divided by 5 plus 30, which is 35. So as a result, what will happen? The combined resistance of a circuit will, the combined resistance of this part will be 4.2. And this combined resistance is 4.2. This combined resistance is 4.2 ohm, and there's also a 20 ohm resistor. So the total resistance of a circuit is 24.2 ohm. And where in this part, the combined resistance was 10 ohm for parallel, and there is another resistor in series. So the total circuit resistance was 30. So in the beginning, the total circuit resistance was 30 ohm. But when the temperature increases, the resistance of thermistor decreases. So the combined resistance of a circuit also decreases, it becomes 24.2. So if the combined circuit resistance decrease, what happened to the reading of ammeter? As the total resistance and current are inversely proportional. If a resistance of a circuit is decreasing, what happened to the total reading on the circuit? The ammeter reading that will increase. So answer here you will mention. Is it clear this part? How the ammeter reading will change? So resistance of thermistor decrease. That is 1 mark. Then what happened? The combined resistance decrease. Of the circuit decreases. And when the combined resistance of a circuit decrease, the ammeter reading will or reading on the ammeter will increase. Is it clear this one?
Yes, sir, clear.